How's it, everyone? Good morning, good afternoon, and good evening, depending on where you are watching this webinar. Firstly, I hope everyone is safe either at home or at the office. Secondly, welcome to our webinar on VSDs with integrated safety functionalities to optimize industrial machines. My name is Altair. I'm a sales engineer at the International Sales Department of WEG Automation, and I am today's webinar host. My colleague Diogo Xavier Schmidt is going to present the webinar. He's also a sales engineer here at WEG, with more than 10 years of experience in drives. Before we start, I have some things to say about the webinar. First, should you have any question, you can write in the questions and answer chat in this streaming platform, and our team of specialists is going to answer it. To make sure the sound quality is good for everyone, all microphones are going to be muted. The webinar will be recorded, meaning that you can watch it later or send to a colleague. To do so, just go to WEG's LinkedIn page and then click on Events. There you can find this webinar, past webinars, and future ones from automation and also from other divisions of WEG. Today's webinar is one of the several we have presented so far, and there is still another one in December. At the end of the presentation, I will inform the topic and the date of 2020's last webinar. So stick around until the end. Last but not least, follow WEG's page on LinkedIn. We share updates about WEG, products, solutions, and also webinars. Without further delay, I will pass you over to Diogo. Enjoy it.
Thank you, Altair, for the nice introduction. And I wish you also a great webinar. Let's talk about variable speed drive with the integrated safety functionality to optimize the industrial machines. So before I start with the topics, let me just to show the main topics we will discuss today. And this is about safety definitions and acceptable risk. Okay. Other topic we'll discuss today is about industrial safety and the main applicable standards for this industrial environment. We'll talk about the risk assessment for industrial machines, the main aspects to approve a system, a safety system, including complete machine and individual devices. We'll talk about architecture design using several examples using variable speed drives, concerning variable speed drives, how it optimizes industrial machines, how it helps our lives in terms of machine design. We'll talk as well about variable speed drive and its main integrated safety functionalities. Remembering that question and answers, you can send your questions anytime. Our team will be here to support you with all the questions. And in the end of the presentations, we can also discuss about some questions in the live. First of all, what means safety? What is safety for you? According to the English definition, according to Cambridge University, state is this one. Safety is this one, a state in which or a place where you are safe and not in danger or at risk. If you are not living in a country that speaks English, I'm sure that you can find other language, other words with the same definitions. But based on this definition, can we state that something is safe or unsafe? But how can we define danger or risk? This is something that it is not easy to do. This is something that's not easy to define if something is really safe or not. And trying to define it in an easy way, I will show you here two different pictures, two different roads, and I will ask you, for you, what is the safe one? How can we drive safe in different roads in the left and the right side? I'm sure that you think that the picture in the left side in the mountains are the situation with a high risk, different than straight road in the right side. But following the local recommendations, I'm sure that's possible to drive with an acceptable risk in both roads. Which recommendations are necessary to drive safely? First one, safe speed limit. So concerning the speed limit, it's possible to drive safely in both roads. And of course, it's necessary to follow other recommendations like maintenance, The driver must have, of course, the license, and the vehicle must have the proper safety design as well, including safety belts, airbag, and so on. But the idea here is to evaluate the risk and to design the car and to drive safely in an acceptable risk. If something wrong will happen, but you are driving safely, I'm sure that you will be safe. I'm sure that airbag and safety belt will save your life. And what about this in industry? In industry, we also have several applications with different level risks, okay? And so it is necessary to design the machines and process to be the most safe as possible, okay? When it is not possible to approve the machine in a requireable, acceptable level, additional safety devices must be installed to reduce the risk to a acceptable level. Additionally, the machines and process must have an adequate maintenance and safety system monitoring. This safety system monitoring will have or will warning in case of any problem to stop the machine in time. Additionally, training and documentation to the user operates the machine safely are required. Okay. And in the end, but also very important, it's necessary to follow all the local standards and normatives to comply with the required safety level. And about standards, which standards we will discuss today? Today we'll talk about the IC and ISO standards, which are the global safety standards used for several machines worldwide. And so we will talk about the IC 61508 and IC 62061 that define functional safety for machines. And additionally, the ISO 13849 that defines the safety requirements and guidance for design and integration of safety-related parts. But of course, there are more standards in different countries that must be followed. So don't forget to evaluate the local standards when you are designing your machine or when you are installing safety components on it. I would like to emphasize here European directives. The European directives are following the same IC, the same ISO standards we will talk today, but of course there are some additional recommendations that must be followed. In the USA, there is the Occupational Safety and Health Administration that also defines the main requirements for safety. And other countries as well, like Canada with the Canada Labor Code and Brazil with the NR12. Please evaluate if you have in your countries different recommendations for safety. So, starting with the IC standards, I will start with this, the 61508, which is defined as the safety features are resources used to reduce risk and warranty the protection of people and equipment in event of potentially dangerous failures in machines or equipment in operation. So this standard is called as functional safety of electrical, electronic, programmable electronic safety related systems. It provides assurance that safely related systems will deliver the risk reduction necessary to achieve equipment safely. What is important here? This is a generic standard, but has international coverage and it's applicable for several applications. We can see here that this standard is used for medical, for process automation, for automotive safety, avionics, and including nuclear power. We will focus today in the standard that's part of this one that defines the condition for machinery. And so we'll talk more about the ISO 13849 and IEC 62061 concerning safety of machine. So checking part of this standard that is related to machine safety, it describes the realization of electrical control system related to machine safety and consider the complete life cycle from the design phase to the decommissioning. It focuses also on risk assessment using a risk chart. Likewise, The validation of safety functions is analyzed using structural and statistical methods. So this standard will define different safety levels according to the application or according to the machine design. The standard defines it and calls it at safety integrity level, also called as SIL. And it defines as relative level of risk reduction provided by safety function or to a specific risk reduction target. It is applicable for industrial machines and also applicable for safety-related parts. It means the safety device is installed in the machine to reduce risk. So we can see here in the blue table that safety integrity level are available from number 1 up to the number 4. Considering the number 1, the applications with low risk, and the number 4, the application with the higher risk level. In the another side, we can see that applications with the high risk level must have a machine or a process with low probability of failure. And if the application has a low risk, it is possible to use a machine with a high probability of failure. We can see here that two different types of average probability of dangerous failure. One is for low demand mode, which defines the minimum and the maximum probability of dangerous failure. And the another one is the same one applicable for high demand mode. The high demand mode is the application that has the possibility of failure with several times per year. And we can classify that low demand mode, such kind of machines that will have a risk or an unsafe situation with more than a year. So in industrial environment, we can say that most of the applications must comply with the second list, with the second table, with very low probability of failure. And how we can define if the machine is safe or not, and how we can classify which safety level the machine must comply. So according to this standard, there are 4 basic questions to define it. The first one is the frequency and duration of exposure classification. It means how long time the people will be in touch, or the person will be in touch with the hazard. Another one is the probability classification. It means the probability of occurrence of a hazardous event. The another one is the probability of avoiding or limiting hazard classification. It means how the operator can avoid it. For example, using any kind of personal protective equipment or using another tools to reduce the risk. And the another one, and here the most important, is the severity classification. If the risk may cause, for example, irreversible injuries like broken limbs, losing fingers, or including death. Or if the classification defines that injuries are reversible, that requires only the first aid, for example. So to make here a simulation of the risk assessment, I use here a hydraulic press machine. This is a typical machine using in industry. And of course, the operator can put, for example, his hands on the machine and cause serious injuries. And how to classify it? Let's start with frequency and duration of exposure classification. This is a machine that has a very fast cycles. It means the press will operate continuously and may have several cycles per hour. And so in this classification, we need to define the number 5 in the frequency and duration of exposure. Concerning probability classification, this machine also will be classified with number 5, because with each cycle, with each press, the operator may have the hands or other parts of the body close to the machine and cause an injury. Concerning probability of avoiding it, there are several things we can use, we can install in the machine to reduce the risk. We can see here in the picture the yellow parts that will protect the operator to touch in dangerous part of the machines. And also it is possible to add, for example, the light curtain, which make possible the operator only to access the dangerous part of machine in a safety condition. But it will not reduce 100% of the risk. And so in this case, we will classify with number 3. Concerning the severity classification, it is classified with the number 3 as well, because this machine it may cause irreversible injuries, including broken limbs, and especially in this case, losing a finger. So in the end, how we can classify the machines according all these topics? Firstly, we will check the severity classification, and we will put here in this line. Additionally, we will do a sum of all the other topics, including frequency, the probability, and also the probability of avoiding. And checking the sum, in this case, 5 plus 5 plus 3, if I'm not wrong, is 13. So we will check here in this column 13 related to the class, and we will find, crossing the line and column, the safety integrity level number 2. And so this machine, in the end, must comply with this safety integrity level number 2, and the components used in this machine also must comply with this safety level. Additionally, we will evaluate as well the ISO 13849. This is another standard that provides safety requirements and guidance on the principles of design and integration of safety-related parts of the control system. So, similar than previous standard, this one also defines different performance level or different contribution to risk reduction that starts with the performance level A, the PLA, up to the PLE. So the PLA, it's a level with a low contribution to risk reduction. And the performance level E is the higher contribution to risk reduction. Just to have an idea, all these levels are linked with different average probability of dangerous failure per hour. Just to have an example, with the performance level D, it defines that average probability of dangerous failure per hour is approximately 1 danger failure every 100 or 1,000 years. So it is a very low probability of failure that may cause injuries or may cause other problems in the industrial process. But in the end, how the machine is classified. So the performance level for machine design or safety devices are based on several factors. For example, the system architecture, how the components are installed, or what is the architecture, the design of the complete machines. It also will evaluate all the components' reliability, the ability to detect a failure that potentially affects the safety function, and also the quality of the project itself. And so this standard will not only define how to classify, but especially how to design the machine in a safety way. And how to do a risk assessment based on this ISO standard. So determination of the required performance level is the result of the risk assessment and refers to the amount of the risk reduction to be carried out by the safety-related parts of the control system. And so in this case, we will not evaluate 100% of the components of the machine, but we will evaluate especially the components part of the safety system. And the risk assessment follows also some basic questions similar than previous standard. So in this case, we will check the severity of injury, the frequency and or exposure to hazard, and also the possibility of avoiding hazard and limiting harm. So using the same hydraulic press machine as an example, we can classify it as a machine that may cause serious injury. This machine also operates with frequent to continuous exposure time. And additionally, it is possible to make some reductions of the risk with the hydraulic press machine, like using additional safety devices. And so we will classify as possible under specific conditions. So following here the yellow lines for the hydraulic press machine example, we will see that the first one answer is S2, serious. The second one concerning frequency is F2, frequent. And also the last question concerning possibility to avoid hazard, it is P1, because there is a possibility to add additional devices to protect the machine. And so in the end, according to the ISO 13849, this machine will be classified as performance level D. It means with a medium to high contribution to risk reduction. But additionally then, the risk assessment, it is necessary to evaluate the main aspects to approve the safety-related control for each performance level. So additionally then, average probability of danger failures, there are different evaluations that must be done with these standards. First one is concerning the quantity aspects. The quantity aspects are basically statistic analysis, okay? It will evaluate, for example, the mean time to failure of the main components installed in the machine. And the mean time to failure, the MTTF, will evaluate in the end how reliable are all the components or each component installed in the machine. Additionally, there is a definition or the statistics concerning diagnostic coverage or diagnostic capability, how the components will monitoring, how the components will find internal failures. Another one is the common cause failure statistics that in the end will check the ability to resist failure. Looking other aspects, the ISO standard also defines that machine must be evaluated according to the quality aspects. And so with the quality aspects, safety system performance in failure conditions will be evaluated as well. And so the standard defines some conditions where it's necessary to follow, or it's necessary to define, to design the machines, to find as well, and to monitoring all the systematic failures. Additionally, this standard also check the safety-related softwares, because several things when we are talking about safety are not only hardware, but also software that makes all the system monitoring. And concerning quality aspects, also safety functions and especially environment conditions will be evaluated here. For example, if the specific components will be installed in a high temperature or in a very cold temperature, or in another side, if the component will be installed in a dusty environment, so this component also must be checked, approved to operate in these environmental conditions. Concerning the quality aspects, I will show you here some different examples of architecture design with the focus on the variable speed drive. So the first example, it's about the performance level A and performance level B. And I use here a very simple example considering a variable speed drive controlling a motor and an external emergency push button. Okay. In case of any problem with the machine or a process, the operator must push this emergency button to stop the motor. So to comply with the performance level A or performance level B, the system must have this behavior here that says that when a fault occurs, it can lead to a loss of the system function. So this system here looks very safe, okay, because there is a connection from the emergency push button to the variable speed drive, and the variable speed drive has also the digital input with an emergency status or with an emergency function that will stop the motor safely. But in the end, this system may have some failures. For example, the cables may have a short circuit, or cables may broke between variable speed drive and emergency push button. And this is for sure an unsafe situation. Additionally, the variable speed drive also may have some failures. For example, wrong parameter setting or other failures with the variable speed drive component that will not switch off the motor in case of a safety problem. But in the end, this is not a big issue to comply with the performance level A or B. In the end, this is approved by performance level A and B. And why? Remembering that performance level N and B is the level that does not cause operator injuries. And so if a problem happens with the system, will not cause any big problem. Talking about performance level C, we will see that additional components must be installed to protect the machine and the operator. And here we will see an external device, in this case, an external safety device. According to the system behavior, the loss of a safety function must be detected by the check. So that is the reason to install external relay in this case, because if the cables has any problem, or if the variable speed drive has any problem, by the check-ins done by the safety relay, it will set a warning to the operator to make the machine maintenance. And so it will stop the machine after detect the failure. But the occurrence of a fault can lead to the loss of safety functions between the check-in intervals. And so there are some conditions that machines will not be safe, but the safety relay will help to detect the main problems and the main faults. This is a acceptable condition for the performance level C, and so this one is also approved. Concerning the performance level D, again, it is necessary to add additional safety devices. And here we will include a power contactor that will switch off the variable speed drive. And also we can see redundant cables here between emergency push button and the safety relays. This system must have another behavior that says that when a single fault occurs, the safety function is always performed. And so this system, when we have, for example, a problem with the cables between the emergency push button and safety relay, the safety relay will set the warning. But again, a second cable, a second connection between emergency push button and safety relay will make sure that the safety signal will be sent to the relay to stop the machine. So that is the meaning of redundant cables here between emergency push button and safety relay. In the power line, also additional protection must be considered, because in case of any problem with the variable speed drive, other components must be available to protect and to switch off the motor in case of problem. So that is the reason to install the safety contactors. If the variable speed drive has a problem, the contactor will switch off the motor safely. And it's happened as well in another way. If the contactor has any problem, the variable speed drive can stop the motor safely. But the system is not able to detect 100% of failures. And the accumulation of the undetected faults can lead to the loss of safety function. Anyway, this is a acceptable condition for the performance level D, and so this architecture design example is also approved. Okay. Concerning the performance level E, we can have here additional devices like safety PLC. And why this one is required in some applications? Because this system behavior is defined as when the faults occurs, the safety function must be always performed. And so it does not matter where the fault occurs, the system and the machine must have the proper self-monitoring to detect the failure, making sure that motor will be switched off safely. So several faults may happen in the contactors, in the variable speed drive, in the cables, and including as well the problems with the emergency push button. And so all these devices must be monitored to switch off the motor in case of a safety issue. And the faults must be detected in time to prevent the loss of safety functions. And so that is the reason that PLC must have the real-time monitoring to protect the system. Remembering that performance level E, in several cases, have more than the emergency push button. In the system, it's common to find the line cortines, it's common to find additional safety switches, it's common to find different safety sensors installed in the machine to protect the operator. And so including more and more safety components will make the system really difficult to have a real-time monitoring. So only if we have this system behavior approved, it is able to comply with the performance level E, the high contribution to risk reduction. So as we spoke, with more and more safety devices will make difficult also to make some analysis of the system. That includes, for example, the risk assessment, all the safety tests required to approve this machine. It's very complicated to make all the quantity aspects. It means the statistics to calculate the probability of dangerous failures per hour. All the safety documentations also will be hard to do with so many components, including also the user training and the proper maintenance of this machine. And how we can do our life easier with so many components. So the idea here is to integrate all these functionalities in the variable speed drive. Adding integrated safety functionalities in the variable speed drive, we can remove several external components to protect the machine. What are the main benefits to do it? The first one, that's easy to understand, that it's possible to reduce the number of safety devices to comply with the required performance level, or the safety integrated level according to other standards for different industrial machines. There are other nice benefits when we are removing as well the electromechanical safety devices like the contactors, because removing the contactors, it makes also possible to control the machine in a fast way, including the safety actuation, and also it's faster to have a system restart by variable speed drive. For example, the variable speed drive needs about 2 or 3 seconds to restart due to the internal pre-charge circuit. And so this time this time reduction also will help to increase the industrial productivity. Additionally, less safety components will make this machine easier to install. It will reduce as well the cost with wirings. It will reduce the cost with the maintenance. And it will save space in the cabinet as well, making possible to design a machine in a compact way. But in the end, how the variable speed drive can control it in a safe way, how the variable speed drive can comply with all the safety standards. So internally, the variable speed drive, or let me start with externally, The variable speed drive has redundant input terminals dedicated for safety, including the external failure monitoring. It means the same thing that external safety relays will do, the variable speed drive also is capable to do, checking if the cables between variable speed drive and external safety components are healthy. Also, the variable speed drive has integrated redundancies with self-monitoring system to detect internal failures in time to avoid the loss of safety functions. And so it includes special hardware with several redundancies and also special software that will do all the self-monitoring of this variable speed drive to make sure that the safety functionalities are running well. The variable speed drive with safety functionality has also the safety programming mode. It means the parameter concerning safety has less risk with programming mistakes. If the user change any other parameter of variable speed drive, it will not affect, it will not switch off the safety functionalities. And in the end, and here the more important, is that the safety functionalities will keep active even with other variable speed drive failures. It means that safety has the higher priority level in the variable speed drive control. If the variable speed drive has any other problem like the overload, like the over temperature, these conditions will not switch off the safety functionalities. So the safety will be always available to comply with the higher contribution to risk reduction. So important that design the variable speed drive safely, it is to certify it also with a third company. And so variable speed drives, the WEG variable speed drive has a certified safety functionality that was successfully approved in all evaluations regarding quality and safety. This certification with TIV has a worldwide acceptance and follows all the applicable safety standards for variable speed drive and machines. The certification also will approve the variable speed drives according to the different safety levels that includes the performance level and the safety integrity level. And also the certification will report to the user what are the applicable statistics from the variable speed drive to make all the calculations required for the complete machines. It means it will define what is the probability of failures per hour, and it will define as well what is the mean time to failure for all the components. So we spoke about the main benefits to use a variable speed drive, but it is also important to know more about what are the safety functionalities integrated in the variable speed drive. The first one we'll talk here is about the safe torque off, or also called by the market as STO. So this functionality, when activated, will switch off the drive output to the motor by means of disabling the supply of torque generating energy. It means that variable speed drive will make sure that motor does not have torque to control the machine. This STO, or safe torque off, is used to prevent as well unexpected startup of machines, for example, for maintenance purpose, fulfilling with the stop category 0. And what means stop category 0? We can see here in the graphic that when the motor is running, for example, with full speed, and when we have an emergency situation, the motor will switch off. It means we will remove all the torque from the motor, and the machine will stop by itself according to the machine inertia. What are the main applications for the STO? So it is designed for all the machines that must have that we must protect personal and machine equipments, and we have a long list of applications that can use the safe torque off, like conveyors, fans, pumps, compressors, hydraulic press, and several other ones. Using the same example we spoke before with the hydraulic press machine, it is possible, for example, to activate the safe torque off when the user are too close of this machine. For example, when the user cross a light curtain, this light curtain may send a signal to the variable speed drive to switch off the motor and to make a safe torque off condition. Additionally, it is possible to use the safe torque off to prevent unexpected startups. For example, the user will touch or will have his hands on the palm switch. So only when the user are with the hands in the palm switch, it will allow the machine to start. So it is possible to use the STO in different conditions to stop the machine or to allow machine to start. Additionally, the STO will also have the function called Safe Stop 1 or also SS1. So the SS1 has a predefined delay time to perform the STO. This delay, in order to allow the variable speed drive to impose deceleration ramp to the motor, providing before remove the torque generating energy. So evaluating the graphic, we can see that different than STO that simply switch off the motor, when the motor is running with the full speed and we have an emergency case condition, the variable speed drive will break this motor. It means will reduce the speed in a fast way as possible. And after the time setting, the SS1 time setting, the variable speed drive will apply the STO. It means the safe torque off condition. And so this function is especially useful in applications where inertial loads needs to be decelerated before the torque removal from the motor. It's also applicable for centrifugals, mixers, dissolvers, mills, and several other machines that must have a braking capability. So that are the main features available in the market, and that are the main features that are required for to install a variable speed drive in a safety machine. And what are the WEG variable speed drive that includes such safety functionalities? I will say here that the CFW700 series and the CFW11 series has the optional version with the STO functionality. This one complying with the both IEC and ISO standard. Concerning IEC, it complies with the safety integrity level number 2, and ISO standard, it complies with the performance level D. And so these two variable speed drive are capable to install with several applications, since performance level A up to the performance level D, without the additional safety devices we spoke before. Additionally, then CFW700 and the CFW11, WEG has the CFW500 with the safety features. And so the CFW500, including the safety module, has the STO and the SS1 functionalities. CFW500 series comply with the highest performance level available in the market and required by the several machines. It means, according to the IEC, it complies with the safety integrity level number 3. And according to the ISO standards, it complies with the performance level E, the PLE. So it is possible to use the CFW500 with this safety module, this yellow module installed here in the top of the drive, with the applications with the low contribution here, low contribution to risk reductions, up to the higher contribution to the risk reduction. Remembering that both variable speed drive, or all of them, CFW700, CFW11, and also the CFW500 are according to the TIV recommendations and are TIV certified. So Additionally, we spoke about the variable speed drive. We spoke about how the variable speed drive can optimize all the machines. But it is important to know that WEG has in our portfolio additional safety devices like the light curtains. We have also the different palm switch to install in the different process and different machines. Machines that require magnetic sensors or switches. We have as well different kind of safety relays to protect the machine and to have a real-time monitoring for different process. Contactors, and especially version safety contactor, also including all the certifications for safety purpose, emergency push button, safety switches, and also some customized solution that will have all the components installed in one single product. For example, this picture here where we can see the emergency push button, including the palm switch and the safety relays installed inside. So, gentlemen, that is all from my side. I'll let you now with Altair that will talk about the new webinars, and later on we can talk about the question and answers we are getting here from you.
Hello everyone, Altair again. So now that Joe can take some time to drink water because he spoke for almost 40 minutes, I would like to present the topic and the date of our last webinar of this year. So the topic is optimization for motor starters, longevity and energy savings for your application. So it will happen on the 10th of December. So in basically 10 days from now, it will happen at 10 a.m. Brazilian time. It means UTC 3. Also, as usual, it will take 1 hour, and the speaker is going to be another colleague from our department, Rafael Shirakashi de Souza. So, just like I said in the beginning of the presentation, follow us on LinkedIn so you receive the updates and posts presenting when this webinar will take place. And let's not forget about our survey. We made a survey so you can assess this webinar. It's available in the chat of this platform that we're using on Microsoft Teams. So we kindly ask you to open it and fill it up. Give your opinion about it, your critics, so whatever you want to say to us. And also if you want to suggest a topic for another webinar, we are also open for it. So regarding the webinar itself, the presentation it's over, but now we will have a Q&A with Diogo once again. But I would like to say thank you for everyone for attending this webinar. I hope you have enjoyed it. You have learned something new for your work. And so, Diogo, now it's with you once again.
Thank you, Altair. We got several questions in the question and answer chat. Most of them we are already answering by chat, but we have some ones here that we understood it's a good idea to clarify to all. Some questions, let me check one here. There is first one, can I use STO functionality to provide electric safe condition in the variable speed drive output cables? I understand that this question intends to make a maintenance in the motor or maintenance in the cables using the STO. This is not allowed to do. Okay, the STO will not provide this electric safe condition because, as the STO said, it is a safe torque off condition. So the main purpose is to provide torque off. It means mechanical protection. If the variable speed drive has any failure condition, it may have also DC voltage in the output cables that, of course, are not safe to the operator. And so, to provide a complete electric safe, it's recommended, of course, to have a switch disconnector in the cabinet or an electric switch disconnector in the machine to make the proper maintenance. Let me check what the question here. The second one is concerning, is it mandatory to use shielded cables from external safety devices to warranty the system high safety level? Well, cables coming from the external components, the external safety relays or external devices like emergency push button and light cortines and another ones may have of course the shielded cables, but this analysis is part of the risk assessment of the machine. And so failures with all these cables will be evaluated, and of course with shielded cables it is possible to reduce the risk of failure. But it is important to remember that a few variable speed drives, especially the variable speed drives that complies with the higher safety level, for example, the CFW 500, this variable speed drive already have real-time monitoring that will evaluate with million check-ins per hour if the cables connected in the variable speed drive are in the good conditions. So in this case, it is not mandatory to use the shielded cables because the variable speed drive will do all the analysis and will inform the user in case of any problem. Let me check here. Do we have more questions? No. So, gentlemen, I would like once again to thank you for this time to watch this webinar. We will keep here available to support you with additional questions. I will be here, and our team also are available to support you by chat. Once again, thank you for your time. Stay safely, stay healthy, and we'll see you again in a few weeks in the next WEG webinar. Thank you very much.